given that k is a positive constant and that this integral is the case, show that 3k plus 5 root k minus 12 is equal to 0. So let's just write out this integral. So we're integrating from 1 to k of 5 over 2 root x plus 3 with respect to x. We're told that's equal to 4. So let's just rewrite this first term that we have over here. So I'll put that on the right. 5 over 2 root x is the same thing as 5 over 2 times x to the power of a half. And then we can bring the x to the power of a half up top. So it becomes 5 over 2 x to the power of minus a half. So then, rewriting this, 1k 5 over 2 x to the power of minus a half plus 3, and that's equal to 4. Okay, so now we can integrate this. Raise the power by 1, and then divide by the new power. So the new power becomes x to the power of a half. That's raising the minus a half by 1. We're then dividing by the new power. So we're dividing 5 over 2 by a half. 5 over 2 divided by a half would just be 5. So this becomes 5x to the half plus the 3 integrates to make 3x. Then you have your square brackets, and you put your limits on the right-hand side, 1 and k. And this is equal to 4. Okay, so now we can substitute in those limits of k and 1. So this becomes 5k to the half, I'll write that as root k, plus 3x, 3k. I'll put this in brackets, you don't have to, but it just makes it a bit easier to see what are the bits where we've put in k and what are the bits where we put in 1. So that minus the same thing, but now putting in 1. So 5 times 1 to the half is just 5, plus 3 times 1, and this is equal to 4. Alright, so then we can simplify this. So I'll just change the order of this first bit as well. 3k plus 5 root k minus 8, and then we bring the 4 to the other side, so minus 4. And then we end up with 3k plus 5 root k minus 12 is equal to 0. Is that what we wanted? Yeah, okay, that's good. Nice. For part B. Hence, using algebra, find any values for k such that this is true. So, what we have there, this is exactly the same as what we have here. There's no difference. So, if we know that this can be rewritten as this, then if we are solving this for k, then we're effectively solving this equation here. So then, for part B, we are solving the 3k plus 5 root k minus 12 is 0. I'll rewrite that as 3 times root k squared plus 5 root k minus 12 is 0, because hopefully now you can see that this is a quadratic, where our variable is root k. So if we put that into our calculator, so put in a is 3, b is 5, c is minus 12, into our quadratic solver, we end up with two solutions. We end up with root k is equal to 4 over 3, and root k is equal to minus 3. But a square root of something cannot be negative, so root k can't equal to minus 3. So this would be our equation that we're then solving. We square both sides of that, and we end up with k is equal to 16 over 9, and that will be our final answer.